Welcome to part 2 of our Tune2 sign build using 4 P5 panels. In the first part we configured our build, we put it all together, assembled it, applied power and made sure that power was running everywhere, and then we were ready to proceed with the installation of Falcon Pi Player. So that's where we're going to pick up. We need to configure the SD card, get Falcon Pi Player installed, and then go through the configuration of it and get it ready and test our panels before we then move on to xlights and configure xlights to write a sequence out that will fit on our instance of FPP. So let's start with configuring our card. So I'm going to take the SD card now, a micro SD card that's used by the Raspberry, and install FPP onto it. So this laptop has an SD card reader, but it needs an adapter for a micro SD card. So I'm just going to put it into the adapter and then insert the adapter into the laptop. Now I've already navigated to the downloads page for FPP. I'm just going to scroll down and find the latest full release. So there we are. So the one that's the release that's flagged latest release is the one that we want. In this instance it's version 3.6.2. So I'll scroll down a little bit further and we can see under the assets section we've got entries for FPP, 3.6.2 for BBB or 3.6.2 for Pi. It's a Raspberry Pi that we're configuring today, so that's the one I'm going to download. There we go, so it's just asking me if I want to open it or save, and I'm just going to save it. Dependent on the speed of your internet connection, this might take a few minutes. So FPP download has now finished, and we need to write the image that we've downloaded, the file, to the SD card. Now, we can't just simply copy the file across because it needs to be put on in a specific manner so that the Pi can pick it up and run with it when it first boots. So I'm going to use a piece of software called Balena Etcher to write the zip file with the image in it to the SD card. Now I'll put a link to Etcher in the description below. So Etcher has now loaded, so I'm going to select the image that we've just downloaded, navigate to our downloads, pick up the file. There we go. Now it's downloaded as a zip file, but Etcher can deal with a zip file, so we don't need to extract that or anything. We can just tell Etcher where the zip file is and it will take it from there. We then double check that we've configured to install to the SD card. As I said in part 1, we've got a 16 gig card, and this is coming out of 15.93, so we've got the right one. And then we simply hit flash and it will write the image to the card. So Etcher has just about finished writing the card. It's now going to proceed with validation to just double check the image that it's written and make sure that it's happy that it matches the checksums. While it's finishing that off, I'm just going to take the network card, the network cable, and connect it into my little switch here, which is connected back to my home network. Now I'm connecting the Pi at this point to my home network to take advantage of my router's DHCP server, which can allocate an IP address to the Pi so that we can get it set up and configured. So I'm just going to go ahead and plug the network cable into the Pi. Now the Pi is not powered up at this time because the SD card is still being validated, and we've got no networking yet. So I'm going to plug the network in. There we go. So that's all ready for us. All we need now is the SD card to be finished. We can then plug that into the Pi, and away we go with configuration. Now occasionally when Etcher gets to the end, it will say down on the bottom right hand corner, the write was completed successfully, and in the middle of the page it will say it's failed. Now 9 times out of 10, if that says it's failed, it's because Windows simply failed to unmount the disk afterwards, in which case it's not a problem and we can just get on with it. So we'll see what happens in this case. There we go. Now exactly as I predicted, down on the bottom right hand corner it says the flash has successfully written, and in the middle of the page it says one failed device. If I hover the mouse over the failure, it says unmount failed. That's just Windows being helpful, and doesn't mean that there's a problem with the disk. So we can go ahead, close Etcher, and take the SD card out. There we are, the SD card is now written and ready to go in our Raspberry Pi, ready to start configuration. So I'm going to take the card and install it in the Pi now. There we go. So the card's in. I can now power up the matrix and we can get ready to find it on the network. So you'll need now to find the IP address of your Raspberry Pi. It will have been allocated an address by your DHCP server, all being well. So you need to go to that, have a look at the leases, and find an entry labelled FPP. That will then give you the IP address that we can navigate to in your favourite web browser on your laptop or desktop to configure FPP and get it up and running. Now I've navigated to our Pi here, and we can tell that it's a brand new build because it's asking us to expand the file system. Now when the image is written, it only uses a small part of the file system to save downloading lots of wasted space. So it needs to now expand to fill the whole card. So I'm going to go to Advanced Settings, scroll down and go to Grow File System. It may need a reboot. That's lovely, that's fine. Let's go for that. There we go. And now we scroll down and it says please reboot. And so I'm going to do so. There we go. So we've done that and now I hit reboot. Yes. And the Pi will now restart. Now because it was allocated a DHCP lease just a few moments ago, it will obtain the same, it will be given the same lease again as soon as it restarts, so we don't need to go and hunt the lease. Dependent on your router, the lease times are normally about 24 hours, so if you come back to it within 24 hours, it should have the same IP. There we go, and FPP has now restarted, the warning bar has disappeared, and we can now crack on with configuration. So I'm going to go to Input Output Setup, Channel Outputs, and then LED panels, because that's what we're configuring. So we start with configuring the panel. I'm not going to enable it yet because we haven't got the configuration ready, so it's not fair to ask it to chuck data out yet. So our panel layout, width by height, is 2 panels wide by 2 panels tall, so it's going to be 2 by 2. 2 by 2. Our panel size, so these are 64 pixels across by 32 high, so 64 by 32, and these particular ones, the ones we sell at Panels R Us, are 1/16 scan. There we go. Our model start will be top left, and the connection is hacked by K. The channel count is something that we need to just verify. Now our panels here, the P5s, are 64 pixels wide by 32 tall, 64 by 32 gives us a total of 2048 pixels per board. We've got 4 of them, so that's 8192. And it's right, it says 8192. Now each pixel has 3 LEDs in it, red, green and blue. So we need 3 channels for each pixel for RGB. Now 8192 pixels in the whole thing, multiply that by 3 for the 3 channels per pixel, gives us 24,576 channels. Now just remember that, because we'll need it in xlights a little bit later. Now I'm just going to adjust the GPIO slowdown to 4. Sometimes the GPIO can run a little bit faster than the Pi Hat can cope with, so we need to slow it down a little bit to keep up. There we go. So that's the top half of this page configured. So I'm now going to hit save. There we go, and move to the second part, which is configuring the layout of the panels on the hat. So we don't need advanced layout because we're just doing a straightforward matrix. And I'm going to do view config from the rear. So uncheck view config from front because I'm looking at the back of it here. Now the back view, this is where we enter the output number and the panel number, so we can tell FPP how it's laid out. Now if you remember in the build we had to do something slightly odd in order to get the cables to reach. So we need to reflect that now in FPP. So our top row is connected to output 3, not output 1. But then correctly we have panel number 1 and panel number 2. So panel 1, panel 2. And our bottom row is connected to output 2 on the hat. So we go for output 2, panel 1, panel 2. And there we go. So that's the configuration of our 4 panels in FPP. So we'll save that. And if I scroll back up, it'll be asking us to restart the FPP daemon. Now daemon is just Linux terminology for the service that runs all the time, that's running FPP. So it's the FPP daemon is like the service in Windows. There we are, that's now restarted. So we're ready to test the panel to make sure that it's working and doing what we want. Now just remember once again the 24576 because we need it now to configure the testing page. So I'm just going to highlight and copy that. If we now go to status control and display testing, we can see that we're now in the place where we can test the panels. Now the channel range to test is rather crazy. Out of the box we get channels between 1 and 8.3 million. Well, we've only got 24,500 channels to test. Now the Raspberry Pi is a very good little single board computer, but it would take it a few moments to go through 8.3 million channels to test, and that would induce some flicker on the board if we're not careful. Now we don't want the flicker, so I'm going to tell it the end channel is 24576. Then it's just got to go through the channels that we have got on the board, and it doesn't waste any time with the other 8.3 million. Now the test patterns, the easiest for a matrix, in my mind, is a cycle. So we can cycle the whole matrix through the different colours. So we're going to go through red, green, blue, white, all as in white, so red, green and blue together makes white, red, green, blue, white and then none, or off. So all being well, I've selected cycle RGB all none, and assuming I've got the configuration right, the panel should now light up when I enable test mode. And absolutely nothing happened. absolutely nothing happened then. I'll leave that in, I could have cut that bit out, but it didn't happen because I forgot to check enable LED panel output. So I shall do that now and save and restart FPPD. Now I'll go back to status control display testing, and I can now change the end channel to 24576 and change the test pattern to RGB all none. All being well, there we go, red, green, blue, white, off, red, green, blue, white and off. Lovely job. FPP is done and we're ready for xlights. So starting with a fresh setup of xlights, this is version 2020.3, so things may have moved on. Knowing the speed that xlights release updates, there may be some differences now by the time you're watching this video. The first thing we need to do is to set the output. So I'm going to add an E131 output for our Pi, and I'm going to set it to unicast, and at this point it's asking for an IP address. Now because the Pi is going to be playing sequences to itself, I'm going to give it a loopback IP address, which you can use the same IP address yourself. It's 127.0.0.1, and that just means it's going to talk to itself. Our starting universe is going to be universe 1 because it's the only prop on this setup, and the number of universes. Now each universe can take a number of channels, and we know that our total number of channels in FPP setup was 24,576. So we now need to work that back and calculate how many universes we need. So using the trusty calculator, we can take our 24,576 and divide it by the maximum number of channels in a universe, which is 512, and that gives us 48 universes. So we can put our number of universes as 48. Our universe size, as I just mentioned, was 512, which is the maximum we can go to. Our description is going to be tuned to. Our controller type is going to be Falcon Pi Player running some LED panels, so FPP LED panels. And that's the controller configured. So we can now save that. And we can confirm, looking at just running across, we've got, it's E131, that's the kind of data that we're running. It's a loopback IP, 48 universes with 512 channels, gives a total of 24,576 channels. So that matches FPP, lovely. We can now move on to the layout tab and put our matrix in here so that we can tell xlights we've got a matrix, and give it the height, the width of the matrix. So I'm going to go to the matrix icon, clicked on it once, and then we can drag that out to roughly the same shape as our matrix here. There we go. So we've got a matrix configured. Now as you can see, it's not set up right at the moment. It's got 16 strings vertically and 50 horizontally. So we need to update that with our own figures. Now our P5 panels have 32 pixels vertically. We've got 2 of them, so we've got 64. And horizontally, we've got 64 per panel, 2 panels, so that's 128. And there we go, that's the basic setup done. Our starting location is bottom left, and that's all we need to save. That's the matrix configured. Really not that arduous after all. So we can now move on and build a test sequence that we can put onto the Pi to test it. So we'll go into the sequencer, and I'm going to start a new sequence, just an animation for now, at 20 frames per second, and quick start. There we go, we're now ready. And I'm just going to simply bring in the butterfly effect because that shows us all the different colours, and it gives us some animation to prove that we've got the video the right way up, it's not upside down, back to front, etc. So let's just bring a butterfly across onto our timeline, and I'm going to expand that to the 30 seconds of this little test. There we go, so we've got a butterfly set up. Now I'm going to render that. That won't take long for this. And save it. So I'm going to save it as butterfly demo. It does, there was one I prepared earlier. There we are. So that's saved now as butterfly demo. And once it's rendered and saved, we can now upload it to FPP directly from within xlights. So if I go to Tools, FPP Connect, it's now going to scan the network. It's done it already, and it's found our copy of Falcon Pi Player running on our Raspberry Pi. There we go. So we'll just double check that's the right IP address. If I flip back, yep, that's the same IP, so we've got the right device. Just double check we're on 362, that was the version we downloaded. The FSEQ type, I would stick with version 2. We've got no media or models to push out. Now the one sequence that we've got prepared, it's found it, butterfly demo, and it's got a tick next to it, so we can simply press upload. Now for us here, that was a very fast upload because it's going straight from the laptop here through the network cable to the little switch down there and straight into the Pi, so not very far to travel. So that's our sequence uploaded. Now we can test that by going back to our Pi, back to our instance of FPP on the web page. I'm just going to refresh this testing page. There we go. And I can now go to the sequence tab, and our butterfly demo sequence is available for us for testing. All I need to do is hit play, and there we go, our sequence is now running. So that's looking good. Our sequence is starting sort of in the middle at the bottom, and it's coming up to top left. If I now check xlights, I'll click on the butterfly. Now we have an issue. Our sequence in xlights is starting roughly in the middle and heading to bottom left. On the panel, it's upside down. Now that's a nice simple fix in xlights. All I need to do is to go back to layout. I'm going to click on the matrix. I'll click off and back on the matrix. There we go. And I'm going to change the starting location from bottom left to top left, thus reversing the order of the horizontal lines. So I'll save that, go back to the sequencer, just click on it, there we go. I'm going to re-render. There we go, we've rendered. I'm going to save it. And then I'm going to push it back out using FPP Connect. There we go, it's remembered all the settings from last time, so I've simply got to hit upload. There we go, and that's the revised sequence now pushed out. And all being well, if I hit play again now in FPP, it's moving down to the bottom corner. So there we go, we've shifted the order of the horizontal lines, so it's now playing exactly as we'd like. Now that's a short run through of how to configure the panel in xlights. So we simply went through the setup. We added a controller at the beginning, told it the IP address, the number of universes, the number of channels, and that it was a Pi running FPP with LED panels. We went into the sequence and added a matrix, which we then configured to show 64 strings vertically, 128 horizontally, and starting in the top left. And we went on to a very quick sequence, just the butterfly, but it demonstrates all of the colors are appearing correctly, and then we got some animation going on the panel. So from here, over to you with your sequencing. Have fun, good luck. Any questions, please do comment below. Drop me an email, greg@panelsareus.co.uk, or find me on Facebook. Thanks for watching. Please do like and share, and we'll have more videos for you very soon. Cheers.